Hey math fans, today we're going to talk about simplifying radicals. Let's get started. Ever since elementary school, you were probably told to simplify fractions, but I'm going to start talking today about how we can simplify radicals. Take, for example, radical 12. It is a product of two numbers in which one of them is actually a perfect square, and because it's inside the radicals, it hasn't been fully simplified. What's the perfect square that's a product of 12? Well, the answer is 4. 4 times 3 is 12, and I can also take the square root of 4. So my final simplified version of radical 12 would be 2 radical 3. Let's try another one. What's the square root of 72? Well, let's start thinking about all the products of 72. Perhaps the first thing that came to your mind was 9 times 8. And 9 is indeed a perfect square. We can take the square root of 9, and we would have 3 radical 8. However, doesn't 8 also have a perfect square inside of it? The answer is yes. 8 is really 4 times 2. So if you think about it, there was actually a giant perfect square inside of 72, which is 9 times 4, which is 36. Now the square root of 9 is 3. The square root of 4 is 2. And remember, once you've taken the square root, it leaves the radical symbol, and you're going to have a 3 times 2 on the outside. Or in other words, the final answer would be 6 radical 2. However, I could have got that from just taking the square root of 36. The square root of 36 would be 6. Again, once you've taken the square root, it gets moved to the outside of the radical symbol. How about the square root of 75 times x cubed? When we start introducing variables, I think it's pretty easy if it was maybe x squared, because the square root of x squared would just be x, but this is actually x to the third. So we're going to have to break this apart into maybe x squared, which is a perfect square, and then you're just going to have a x that's left over. Not to mention 75 also has a perfect square in it as well. 75 is really 25 times 3, and of course 25 is a perfect square. And then we have x squared times x. Square root of 25 is going to be 5. Square root of x squared is going to be x. So you're going to have 5x on the outside. Square root of 25 is 5. Square root of x squared is x. And then you still have a radical 3 and a radical x left on the inside. And now we're getting into some challenging ones. So now I have 3 times square root of 40 times x to the 10th power times y to the 6th times z. And I want the square root of all of that. So I'm going to have to start thinking, what's the perfect square inside of 40? Perhaps something already came to your mind. But we have never taken the square root of something like this before yet, or y to the 6th. Let's talk about that. What would the factors of x to the 10th be? Well, we could factor out a bunch of x squareds. And here I have x to the 10th factored into x squared times x squared times x squared times x squared times x squared. Or we could be a little smart about it. Isn't x to the 10th really x to the 5th times x to the 5th? In other words, if we were to take the square root of x to the 10th, we'd get x to the 5th. And if we were to take a look at y to the 6th, we could get y to the 3rd times y to the 3rd. So the square root of y to the 6th would just be y to the 3rd. Or in other words, every time we have an even exponent, if your exponent is even, just divide by 2. And that should get you what the square root of that variable will be. So in our problem, we have 4 times 10 is 40, 4 being the perfect square. X to the 10th is already a perfect square because it's x to the 5th times x to the 5th. Y to the 6 is already a perfect square because it's y to the third times y to the third. And then poor z is not a perfect square, and it will have to remain inside the radical. Now we will take the square root of each of these. And remember, when you take the square root of something, it gets moved to the outside of the radical, and it also gets multiplied by whatever's already out there. So just FYI, take a look at the 2. It's going to be multiplied by the 3. We always multiply by whatever's already out there because the 3 was already being multiplied by the radical anyway. So it's going to be 3 times 2 on the outside of the radical. And so our final answer is 6, x to the 5th, y to the 3rd, square root 10z on the inside of that radical. To add and subtract radicals. Well, you know how we have 2x plus 5x, that's going to equal 7x. So if we have 2 radical 2 plus 5 radical 2, that's going to equal 7 radical 2. It behaves the same way, but they have to be like radicals. What if we were to do subtraction? 14x minus 4x, you get 10x. So if it was 14 radical 3 minus 4 radical 3, you would get 10 radical 3. And in this instance, both of them were radical 3s. And the other one, they were both radical 2s. So just like x's and y's, as long as they are like radicals, you can go ahead and add or subtract them. Ooh, what about this one though? This one we can't add them because it says radical 8 and 3 radical 2. However, I wonder if we could make radical 8 look a little bit different. Oh yeah, it could be simplified, right? It's got a perfect square in it. So if we simplify this, we get 2 radical 2 plus 3 radical 2. Now they're both radical 2s, and we can add them 5 radical 2. So you might have to do a little bit of manipulating and simplifying before you add. Of course, if these were different radicals, they would just stay how they are. And sometimes you'll get that. What if you have radical 2 plus radical 3? That's it. You can't simplify it anymore. How about multiplying radicals? The cool thing about multiplying radicals is you do not need like radicals. I can multiply radical 2 times radical 6. The only rule you have to follow is if it's underneath the radical, it needs to stay underneath the radical. So they're both underneath the radical, so it's really going to be radical 2 times radical 6, which is radical 12. But hold on. Before you circle this and make this your final answer, is there a perfect square inside of 12? Can I simplify it more? The answer is yes. 4 times 3, right? And so it's going to simplify to 2 radical 3. How about this one? Well, here I have 2 radical 3 times 5 radical 2. How can they don't need to be the same type of radical. I can multiply these together, but the rule is this. If it's a number inside the radical, it can only be multiplied by another number inside the radical. And the 2 numbers that are outside the radical, 2 and 5, will get multiplied together. So notice, I'm multiplying the 2 and 5 on the outside, and then the radical 3 and the radical 2 on the inside. You're going to get 10 radical 6. So here's the rule. The rule is this. For multiplying radicals, whatever's on the inside stays on the inside unless you can simplify it after you've multiplied it. So look in both of these scenarios. I got a radical 54 and a radical 12. Both of them have perfect square inside, which you can take out later on. But yeah, numbers on the outside of the radical stay on the outside. Numbers on the inside of the radical stay on the inside. But when you're adding and subtracting, they have to be like radicals. In this case, I got 3 radical 6 and 5 radical 6. It's going to be 8 radical 6 as your final answer. And radical 5 plus radical 5 is really just 2 radical 5. All right, and that's going to do it for this video. We'll see you in class.